Yeah, we are live now. So, welcome you all to this session with CSEA. This is our fourth talk, and we are today with Mr. Gaurav Sen, and he'll be talking about system design and competitive programming and their role in software domain. Welcome to you, Gaurav, and thank you for doing this session with us. Thank you so
Thank
much.
you, Abhishek. Thank you, all the NIT Warangal made this possible.
So let us start with an introduction for our association. So, CSE or Computer Science and Engineering Association NIT Warangal is the official branch association of our college, which was started in 2002. And we work continuously for the welfare of students of our college regarding all the technical sides of our branch. And the CSEA conducts events around the year for the benefit of students of not just CSE but other branches as well. So we conduct several events like talks with CSEA, where we gain from experience of our alumni and those who are not presently alumni, and straight out of CSED, where we bring out inspiring stories from our CSE department, hackathons, collaborations with several organizations to conduct workshops on web development and machine learning and a lot more, and coding contests, quizzes, among a lot of other events. So now our team works tirelessly to bring out the best content under the guidance of our faculty advisor, Professor S.G. Sanjeevi. And the hard work has paid off as well, as we have been the best association in NIT Warangal for the past 2 years. So I welcome you all to this fourth episode of Talks with CSEA, which also happens to be the first one of this year, with our esteemed guest, Mr. Gaurav Sen, on the topic of role of system design and competitive programming in software domain. So again, heartiest welcome to you all. And so let me talk something about Gaurav now. So he's an experienced software engineer, competitive programmer, a YouTuber, and founder of InterviewReady, which is a startup. After graduating, he became a part of Morgan Stanley as IT analyst, switching to DirectI and then to Uber. And amassing his knowledge and experience, he founded his startup InterviewReady, a platform that offers a course of system design for interview preparation with a user base ranging from software engineering to project manager. It has a wide user base. And on his YouTube channel, Gaurav Sen, he talks about interview preparation, system design, competitive programming, algorithms, and everything that will make you a better programmer and a software and a better technical person in a software domain. His YouTube channel has a huge subscriber base of more than 3 lakhs. And if you are preparing for system design, then you must have definitely stumbled upon his playlist of system design on YouTube. So without further ado, let's start this session. And thank you, Gaurav, once again for joining us. And it's really an honor. So thank you so much.
Thank you, Abhishek. That's a wonderful introduction. Thanks to Divas and everyone else also who made this possible. Welcome to all of you from YouTube and Airmeet who are joining us today for a session on competitive programming and system design for software engineers. So the agenda of this session is to think about how is competitive programming or system design useful for software engineers. That's not always the case, especially with competitive programming, but I will take a few exceptions to kind of highlight that how competitive programming can be useful for software engineering. That will be the start. Then we'll move to system design as practical as possible. We are not going to be talking about scaling. We are not going to be talking about many of the extreme details of system design. We are going to be talking about high level, hackathon level system design, you can call it. And then finally we'll be taking questions from Abhishek, who's going to be asking some interesting questions. So let's start.
Yeah, so we'll start with the presentation from Gaurav's side. So I will mute my mic now so that you can concentrate on the presentation. So let's start.
Awesome. Okay, so guys, the first thing I want to talk about is competitive programming. Why should you start it as a person fresh in college? I think most of the people who are watching this, including NIT Warangal, are people who are in college and maybe considering starting competitive programming. So as a software engineer, the usefulness we'll see. But for your interviews or for improving your algorithmic skills, this is a pretty useful path to take. Why is that? Because one, you get to improve your coding skills. So if you have an idea about how to solve a problem, you actually get to code and then check whether your code is running or not. So it's not just about syntax, it's also about how do you talk to a computer, which a programmer needs to know very well. So computer programming gives you that opportunity to code solutions and interesting solutions on top of that. The second thing is application. For example, you know about Dijkstra's algorithm, you know about sorting, you know about many of the algorithms that you're taught in college, but where do you actually apply them? That becomes a task. Computer programming gives you a good set of problem solving, you know, competitions where you get to look at a question and think about how do I solve this question, and that's where you apply your algorithms. So many people have an issue with application. They know the algorithms, they don't know where to apply them. Computer programming provides that bridge. And finally, it's easy to start. This doesn't require a huge investment in terms of time, effort, or money. Computer programming, you can just head on to a site like Codeforces right now and just register yourself for the next contest or to start practicing with the already existing problems. So that's why I'd recommend computer programming to you, especially if you're in second or even first year. If you're in third year, I hope you have already started with computer programming. But if you haven't, you can try it out. It's interesting. It's not necessary. I'm not saying that this is the only way to get, clear your interviews, but it's definitely useful to improve your skills in algorithms, which eventually turns out to be useful as a software engineer also. Okay, so let's take the most common scenario. This is not as a software engineer. This is as a interview for a software engineer. Okay, computer programming. So this is us, and if you do computer programming, then this is you confident. So I'll take you almost 6 years back to my interview at DirectEye, where I was asked a series of questions and I was not doing very well. So eventually you get a deal breaker kind of a question where if you solve this, because it's so hard, you still get a chance. If you don't solve it, then, you have not solved the earlier questions anyway, so we should probably reject you. So that's my understanding of the thing. I'm not claiming that this is what happened. But yeah, this was a tough question, and I think it was sort of a deal breaker question. Okay, so what is the question? The Josephus problem is the basis of the question. Guys, okay, yeah, there's everything is fine. I think 58 people are online. Okay, so let me describe the problem to you. The first thing that we need to know is that we have n people in a circle, and one person has a sword. Okay, this is Josephus problem, which was thousands of years back. I think a General Josephus solved this problem on the spot, so that's why it's named after this person. On every turn, the kth person from the person who's holding the sword is killed. So if you are holding the sword and there's a circle of 10 people, if k is equal to 5, you go to the fifth person from you and you stab them. So they die. They're out of the circle now. So the circle contracts. Okay. Now you have only 1, 2, 3, and 5 alive because k in this case is equal to 2. And 2 was holding the sword, so they killed number 4. The sword passes to the person next to the person who has died. So 5 gets the sword. You kill the second person from here, which is person number 2. Okay. So now you have person number 3 holding the sword. They will kill person number 1, 2 away. Now 3 still has the sword because the next person from 1 was 3. And now they're going to kill someone who's at a distance of 2 away, which is in this case a suicide because 5 and then back to 3. So they kill themselves. And the winner of this challenge is person number 5. Okay, so this is the Josephus problem. Josephus supposedly had won this, and supposedly he had also made sure that the other person who Josephus was supposed to kill was a friend. So that's the mythology behind it. But our job today is to make a circle of n people and then have 2 kinds of operations. So if you have done computer programming, this is an extremely common template of problem solving. First one is A, kill the next person. So whoever is holding the sword right now, current person, current index, plus K will die. They'll be removed. And the second one is find the number of people alive in the range I to J. So everyone has indexes, like we said, 0 to 5. And over here, if I say how many people are alive, in this case from 2 to 4, then 2, 3, 4, all 3 are alive, so the number is 3. Now if I say how many people are alive in 2 to 4, 2 and 3 are alive, 4 is dead, so the answer is 2. So I'll give you any random range I to J, and you have to tell how many people are alive in that range. Okay. So those are the two kinds of operations we need to perform. And remember that these two operations are coming at any point in time. So they say kill, kill, then they suddenly say, okay, how many people alive from this range to this range? Then again, they say kill a few other people, and this keeps happening. So our job is to answer both types of operations, basically answer both types of queries efficiently. So I'll give you 1 minute to think about how do you solve this problem. Like, what kind of data structure or what kind of algorithm can you use for this? 30 seconds. This is a pretty common template of solving complex programming problems. As we'll see, there's a reason why this template is so popular, because simple data structures don't work. And that's why it gives you an idea that maybe you need something big. Okay. Okay. So let's try and solve this. The first thing we have to think about is how do we represent these people. So we have already said from I to j, the number of people who have died, we need to be able to tell how many people have died. So there is some information I to j, which is the index of the people. So for every person, we need the index that they're standing on. That's one thing that we need. And the other thing is, are they alive or are they dead? So that's a Boolean true or false. So for that, you need in total an integer for the index and a Boolean value. So the perfect data structure for this is a Boolean array. Rocket science. So if you have 5 people over here, and let's say person at index 1 is killed and person at index 4 is killed, then you have this array till now. Okay, so and if I ask you, find me the number of people alive from index 1 to 4, then all you need to do is do a straight, you can use a for loop 1 to 4, how many people are alive. So that will be 0, 1, 1, 0, 2 people alive in total. Yeah. The problem here, as you know, is that if you use a for loop in a linear array, and the maximum size of the range can be n, so the number of queries is q, number of people alive in each range is n, so that is q into n. So that's a very large number. You don't want that. It's going to be too slow. It won't be accepted in the interview, basically. Okay, so the time complexity is order n. What can we use? To speed up querying, we can use a technique, a special algorithm called prefix sums. So again, you have the original array, but this time you're not going to just run through the array and try to find how many people alive in a given range. You're going to pre-compute something, which is the total number of people alive from start to a particular index. Taking this example, prefix sums is number of people alive in 0, or basically prefix sums is from 0 to this index, how many people are alive, right? So for 0, that is just the total number of people alive there. So that is 1. For the next one, which is index number 1, the number of people alive from 0 to current is the total number of people alive now, which is in this position, and all the people alive behind me. So that's where the formula is coming from. The total number of people alive, A of I, that is in this position, plus the total number of people alive behind me from 0, which has already been computed. So you're seeing how we are computing this. We have prefix sums 1 over here. The next one, we are just taking one value from above and pushing this value forward to give 0 plus 1, which is 1. 1 plus 1, which is 2. So the total number of people alive from index 0 to 2 is 2. But we didn't run through the whole array to get it. We just took 2 values. And what's happening here is, because we are taking just 2 values at every step, the total number of computations we are doing for n number of people is 2 into n. So that is order n in total. But order n plus the query time is what we'll see now. Okay. For any given query, I to j, the prefix sum, or rather, let's think of it this way. It's rather simple, okay? How many people are alive from I to j? the number of people alive from 0 to j minus the number of people alive from 0 to I minus 1. Okay, this is an intersection. You can think about the set intersection that we have. So these colors are really easy to understand. The total number of people alive from index 1 to index 4 is the total number of people alive up to index 4 minus the total number of people alive up to index 0. You can see the set intersection over here. 3 minus 1. So I'll give you 2. So instead of running through the whole array, you're just finding two values, I and j, plugging them and getting a solution. Okay, so this is order 1. Yeah, this is the Venn diagram thing that you can think of. This is fast. So every query will be answered in order 1 time. So if you have q queries, you answer in order q time. It's extremely fast compared to order q into n. Multiplication of those two terms would have exploded the amount of time required. But there is a problem. Despite this being order q, we have, like we said, we have two types of operations, right? That's the problem. You can find the number of people alive in I to j very quickly in order 1 time. But how do you kill the next person now? Original array. We said we have found prefix sums. Let's say we kill at position number, at index number 3. So earlier we had prefix sums as 1, 1, 2, 3, 3, meaning the total number of people alive up to this point. But once you kill 0, the total number of people alive in the subsequent points have all changed. They have decremented by 1 because one person was alive there. So we have to recompute those values for prefix sum. And that means that in the worst case, on every kill of a person on one type of operation, operation type 1, where you kill a person, you have to run through the entire array and fix all the values. Okay, so your updates are really slow, but your queries are really fast. Too bad, our updates are still order n, which means in the worst case, you'll have q queries of type kill, and each of them is going to take order n time, so that's going to be order qn. So it's still bad, and what can we do about this? Okay, I'll give you guys another minute to think about it. I'm sure many of you had thought about this in the very start, but yeah, this is how you build up the hype around a data structure which is supposed to be used only for computer programming. So yeah, 58 seconds. Yeah, but the basic idea here is that you need a range data structure. So any of you who know about range data structures but who haven't coded it out, this is going to be pretty useful. There's multiple ways to do this, as we'll see after 30 seconds. Oh, here's an interesting thing. I can give you 5 minutes, 10 minutes, 15 minutes, but I guarantee you're not going to be able to come up with this data structure by yourself. Maybe through the internet you can, but that's one of the strange things about these hard problems in computer programming. If you know about it, good. If you don't, then there's no way. So in some cases, I hope this is not very common, but in some cases, if a computer programming question, a high-level data structure comes in, the only way you can solve it is by actually being a computer programmer. Okay? Like I said, it's not common. Maybe 1% of interview questions are like this, but it does happen. I have seen it happen multiple times in my own experience, and I have talked to people who have also had similar experiences where, you can't solve the problem by thinking logically alone. You have to have some theory backing you up. Okay. So let's talk about the solution. The solution to this is finding a range data structure, and the one that we are taking is a segment tree. So yeah, if you use a list, if you use an array, problems are there. If you use prefix sums, there's still problems. Segment trees or square root decomposition will solve the problem for you. And segment tree is the most efficient way to go about this. Let's see how. So initially you have this array. What I'm going to do is I'm going to build another data structure on top of this. Okay. You have the original array 1 0 1 0. I'm going to take two elements together and combine them and find a representative for that element. Okay, what do I mean by that? If you have an office, there are employees and there are managers and there are senior managers and then there are directors and so on and so forth. each person is responsible for all the people under them, but they are not directly connected to all the people, because that's going to be a very, very it's going to be a very dense relationship. So instead, what you do is you have just a few reportees with you who themselves have more reportees. That's what I'm doing over here in the segment tree. How many people are alive from index 0 to 1 is going to be answered by this node. So that is 1 plus 0, which is 1. How many people are alive in the range 2 to 3? That is going to be answered here, 1 plus 1. Now I'll say how many people are alive in the range 0 to 3. So do I go through all 4 nodes? No. I just ask the subordinates how many people are alive. That is 1 plus 2, which is 3. And over here now the segment tree is being built slowly. I can't go to the root node now because the right hand side is still missing. So I have to go all the way down and ask how many people are alive here. It's an interesting scenario. You have 0 people alive plus null. So over here you have to think about what does your segment tree do. So if it's summing things, then you need an identity operation. So x plus something has to be x. In our case, it's going to be 0. But if you have multiplication, then x into what is going to be x. So that becomes 1. So your identity becomes 1. Anyway, that's what we have, 0. Same logic. And then you have 3 people alive total in the segment tree, which looks very obvious because you have a very small array. But if you have a large array, this is extremely helpful. And let's see how. So let's say query comes 1 to 4, how many people are alive? So the answer we can see is 2. But like we said, if people die, then you have to do a lot of stuff. So how do we answer this? 1 to 4. First, we go to the root node. We say our range is 1 to 4. The root node says my range is actually 0 to 4. So you are within my range. So I don't know where to send you. You go to both my children. You ask my reportees how many people are alive. Then I go to the left hand side, and over here I say my range is 0 to 3. Why is it not 1 to 4? Why is it 1 to 3 rather? Because the maximum range over here is 3. So I'm just truncating that part off. And the node says my range is 0 to 3. You are within my range, but I don't know exactly how much. So again, ask both my children. Over here to the left, range is 1 to 1. Node range is 0 to 1. I don't know. You're within my range, but not exactly. I don't know where. So go to both my children. And over here, node range is 0 to 0. The actual range is 1 to 1. You're out of my range. And I'm going to return an identity operation of 0. From the right, I have completely occupied your range. So I return a 0. Overall, 0 plus 0 is 0. And now I come to the right. Over here, the interesting thing of completely encapsulating the range happens, because my initial query was find me all people from 1 to 4, I think. Yeah, 1 to 4. So over here, the range 2 to 3 is completely encapsulated by my original range. So tell me all the people who are under you directly. I won't be going to them. You'll answer directly. So the node 2 returns a value 2 without going to its children, and I saved 2 computations over there. Instead of going down, I just directly asked. So now 2 is returned over here. And similarly, if you go in the right, the same thing will happen, and 0 will be returned to give you the answer of 2. Okay, so that's how you query. If you want to know why this is efficient, I'll probably share a link of a video later on where I explain segment tree complexity. But now the other challenge. How do you kill the next person? How do you kill the person K away from you? So let us assume you identified who has to be killed, the next person K. Initially we had 1 plus 1, the parent was 2, then 3, then 3. Now I killed that person, so there's an update being sent upwards. So go to your parent and say, I'm dead. Your parent says, sum my children, 1 plus 0 gives me 1. Go to your parent and do the same thing. So its parent goes and sees 1 plus 1 is 1. And similarly, the root is made into 2. So what we have done is we have sent an update, we have propagated an update all the way to the top of the tree. That's the general idea of a segment tree. Now, this works like 90% in our problem. Of course, we are saying kill the kth person, which is not so simple. So you can probably leave that solution in the comments. It's a little more involved. The problem is there's a lot of edge cases you have to think of. Okay, there's one on persistent segment trees video, and that might help you figure out if you want to kill the kth person. Basically, you have to start from the root. and then you have to see how many people are alive in this side. If less than k people are alive, then you go to the right hand side. Otherwise, you go to the left hand side. That's the basic idea. So, but yeah, do give it a try and let me know if you solve it. But yeah, you have to apply this to the given problem. That's like that was the interview. Okay, so it's not a very strong case that I have for computer programming in software, but it helps during interview preparation, especially for freshers, uh, which is like most of you guys, I'm sure. But B, it also helps you get better at algorithms, and that is difficult to measure. It's like getting better at math or something. It's very hard to measure what is the impact that getting better at algorithms does, because your system design improves, your software engineering also I think improves. You become more confident, I think, when you get better at algorithms, because the core of computer science is kind of taken care of. So your theory is, at least one subject in your theory is strong. So that would be my selling point for computer programming. And later on, of course, we'll be taking questions. You can post your questions and I'll try to answer them. But we'll take a 1 minute break now to head to the next topic of this talk, which is system design.
Yeah, great. That was a really great problem that you explained, Gaurav.
Thank you.
And
Thank you, Abhishek.
yeah, we had a few answers actually. Segment trees and then circular linked list. Yeah,
Okay, that's great. Circular link
Fenwick
is a
tree.
really good idea, yeah.
Yeah, Fenwick tree. We have a Fenwick tree as
Fenwick
well.
tree will also work. Cumulative sums will work here.
Yeah.
Yeah, these are all good ideas. Fenwick tree, I think BIT is the same thing. But
Hmm.
yeah, you guys are all right. Circular linked list unfortunately does not work because the complexity is high compared to a
Hmm.
segment tree in this solution. Problem with the circular linked list is that you can kill the kth person through k operation, so order k. But then finding the number of people alive from I to j becomes another challenge. So order
Yeah.
n. So yeah, that's a problem. But good try. Okay, apply this to the given problem. I think I'll wait for half a minute again, just so that you guys can absorb this, and I can drink water. That's also very important. Okay, now that I don't know what I mixed in this. Anyway, let's get to the next topic, which is system design. Okay, and the reason I have picked a very small subset of system design in this talk is because I want to make it as software engineering as possible. To be honest, though, system design, there's a lot more depth to it. The more you read, the better you get, and there's a lot of things. But I am going to be focusing on just the high level things on system design, something that you can use in a hackathon, something that you can use in practical life in college. Yeah, that's what I'm focusing on. I'm not going to be focusing on too much on how is the system going to be extremely reliable. How are we going to horizontally partition things, and how do you take a large problem, break it into an abstract problem, and then find abstract solutions for that? That has its own use cases, but in this talk, I'm going to make it as actionable, tested, and practical as possible. All the advice that I try to give you. Okay. Why is there two emojis on the start? Actionable. Okay. But yeah. So the first thing that you want to do with system design is identify which part of your system actually needs design improvements, because some of them can just be made immediately. For example, if you are making a complaint portal and people are sending their complaints, then do you directly send a request response and store it in a DB and just go ahead? Well, if your scale is really small, then okay, there's no problem. But once the system starts scaling, that's the time when design becomes a really important consideration. However, there are certain decisions that you need to make at the very start of a project. So let's get to those. The first one is choosing a database. I've seen this in hackathons, I've seen this in startups. How do you choose a database? And everyone talks about let's use NoSQL or let's use SQL, or my problem is really graphy problem, so I'm going to use a graph database. Okay. What I would strongly recommend you guys to do is to, when you're choosing a database, think about APIs instead of the internals of the database. Uh, why? Because if you think in terms of APIs, you understand is this database offering me, not what it does under the hood. What it does under the hood is extremely important, but usually if the thing is a popular project, what it offers is a reflection of what it does under the hood. Okay, if it's giving you stuff like find nearby connections and all, it's probably a graph database internally. If it's saying key value pairs everywhere, it's probably a key value pair thing like Redis. Okay, so useful for caching if it's going to be a memory, if you're going to load it in memory. So think about APIs, think about what it offers instead of what is inside it. Uh, if you're still confused on NoSQL and SQL, I'd say SQL is usually a little cheaper to start off with if you're going for cloud solutions. So that's a positive. SQL is also well known, although NoSQL is also very well known now. NoSQL gives you some flexibility in terms of your schema, but really SQL also for small scale, what's your problem just hitting an alter table query? Okay, because it's not like you're going to crash the system, right? Just going to delay maybe one request. So there's things to consider. I would still say SQL is a good place to start with. SQL, I mean RDBMS, relational databases. Yeah, and whenever you're actually using a database, make sure that the integration cost of the overall system is low. So if everyone in your team wants to use Postgres, and you're the only person who wants to use GraphQL, and then you say I'm going to make a separate part of the project which is just using GraphQL, but everyone else can use Postgres, that's also not going to help much. So in general, you want to move along with the team as much as possible. Okay. The other thing is integrity checks. When you're just starting with your system in college, even in your projects, I've seen a lot of people say that, okay, I have added this trigger. When this happens, then this has to also happen. A stored procedure will run, which will make sure that this is also the case. I'll tell you what's the problem. The problem is testing. If you want to add a complaint to your portal, you can't just do that. You have to make sure that the status database is also working, like the table is also running correctly. You have to make sure that this can't be ABCD, be a UUID. Like, adding those constraints does not help much, honestly. I have not seen production systems also have a lot of constraints. Only if they are extremely important. For example, financial databases, that's the only time when I've seen that people are actually adding tons of constraints because they don't want any data corruption or any integrity, check failure. But when you're starting off, don't add these things, don't restrain yourself, keep things flexible as much as possible. Okay, a lot of the things that you're hearing right now might be like, how is this system designed? It's actually not. It's more about software engineering, good software engineering practices. And you can maybe construe it as a part of design, but yeah, I think this is pretty important, especially in today's day and age. Just keeping these things in mind. The third thing is scale. How does scale help in software engineering? Well, scale makes everything complicated. Uh, Again, if you're just starting off, if it's a college project, don't worry about scale as much as worrying about how you actually implement these features, or how are you write the code so that tomorrow you're not going to feel like deleting the whole file. There's many things to consider in a college project which are probably not going to be do with scale, unless you say that I'm building something on top of Aadhaar, or I'm building something on top of a imaging system. So the time required to handle each request is a lot. So then you try to vertically scale the system, make the code more efficient and stuff like that. Otherwise, focus more on features, focus more on making the code correct, than thinking about what if a million users come here. Okay, because if a million users come here, you're probably going to get funding and you're going to hire actual engineers. That's also useful. Okay, guys, I'll give you a minute to formulate your thoughts on this, which is choosing a database. Most common thing to do if you are just starting off with system design. What's my favorite database? S3, I think. Yeah, it's not even a database. It's just a file system. You dump whatever you want. Unfortunately, it's not very efficient if you're thinking about querying things. Yeah. Okay, let's head to the next part, which is okay, which is quite interesting. Let me give you a backstory of this. First part we talked about is making decisions based on what a thing offers than what it does really. So the second part is best described by a story. There was a particular share, okay, which was being sold in the market, and it had an IPO. So what happens is when you go to an investment bank and you say that, can you do my IPO? What you're saying is, find out how much wealth I have, which a chartered accountant can also do for you. But these guys are supposedly experts. So they find out how much wealth you have and the number of shares that you have put out in the market. So if your company's valuation is $1 billion and you have put out 1,000 shares, so each share will be worth 1 million approximately. Okay. Now that's an expert thing. You can't do it yourself because you'll say my every share value is $10 billion. So that's the reason why you need third party to do this. But they give you a sort of a guarantee. They say that our valuation is correct. If when we say that it should be $1 million and nobody's buying it, then we'll start buying your shares to increase the share price. Okay, so that because we are so sure that you are actually $1 million that we'll buy it. And if people are buying it a lot, then we'll sell some shares of ours because we believe that it is close to $1 million. That's the general thing. They try to keep the price close to the valuation price once an IPO has happened. So initially, this is what was happening. The company's share price was said to be in the dotted line, but you are below it. So the company made a mistake. The valuation was wrong. It was too high. So the investment bank said, let's buy some shares. And boom. Like lots of shares were bought. People saw that the share price is rising, so everyone started buying it. Then what happened is that there was a big crash. Why? Because the company which saw that they have bought all these shares started selling shares quickly because they made some mistake here. Okay, and looking at that, everyone lost confidence in the share, and everyone thought that okay, this is the time to sell. So it crashed, and this is a disaster. Basically, if you are an investment bank and you see this in your graph on an IPO day, it's not a good day. Okay, yeah, you're probably going to lose a lot of contracts and get a lot of suing. So why did this happen? Can anyone guess in the comments? I'll give you 10 seconds. I think I'll give you 30 seconds. I won't be looking at the comments, but just try and guess what happened. The blue part is not a mistake. The blue part is a natural reaction. People started selling. Looking at the the investment bank selling, everyone started selling. That can't be stopped. The red part is the mistake. It should have hit the dotted line. It should have not exploded. What do you think is the issue, engineering wise? Okay. The issue was that you had something called TCP error. So when they sent the order of buy, when the investment bank said buy these shares to the stock exchange was supposed to return an acknowledgement of yes. That didn't happen. So in TCP, you might know there's something called a retry, and there were retries, 50 of them. And that's the reason why the share price completely shot up. Uh, Problem was that nobody had actually tested for retries. I mean, retry failures in the stock exchange. It's shocking, especially for a for an investment bank, right? It deals with this all the time. So yeah, basically, there was a big report on why this happened. There should have been a last mile transaction validation, like just before buying the shares, there should have been a validation engine which made sure that, oh, is this transaction making sense? There should have been alerts. There should have been exponential back off. You shouldn't have like fired so many retries. You should have done that with exponential back offs if it's not working. But the thing which is actually most relevant and the thing which we can do very easily is testing. Yeah, that is not done. You can call poor documentation. You can call idempotency, everything, rate limiting. but testing is testing. Okay, and yeah, if you want to know what happened, then a lot of people were fired basically because testing was not done. Okay, so why do you do testing? It saves time. It saves time because your time on debugging and reading logs is saved. That's a big thing. Uh, then B is it avoids manual effort. Once you have written a couple of tests, all you need to do is hit the play button and it will run again. Otherwise, and I've seen this happen, manual testing, you have to run through the same scenarios, which is cognitively very taxing. And the other thing is, you might skip one test by mistake. So, even, as software engineers, definitely write your own tests. Okay, so that will avoid the manual effort, builds confidence, that's okay. Reduces bug scope. If you know that there is a bug, then you know that these things are already tested. There's only some gaps where things are not tested, maybe in the integration or something. That's where you need to test. Debug basically, so that's okay. And documents expectations, this is I think more fluff than anything, but yeah, some people say that I read the test cases and then I decide whether this code is making sense or not. Maybe really, maybe, maybe, but at least the first 3 points make a lot of sense. Okay, yeah, that's why I highlighted them. Okay, uh, now the final thing actually of system design that I'd like to talk about is observability. What is this? So I was reading an article on this, and it was saying that logging is like writing lines, like telling you what is the current state. Observability is like telling you what is actually happening. So if you're looking at wildlife, okay, and you see nails going into a prey animal and then etc etc, that would be logging. But if you see a lion hunting a deer, that would be observability. Okay, you get the larger picture of what's happening, you get an overall idea of what is the health of the system, you get an overall idea of how these systems are behaving, which is under pressure, those kind of things. Okay, so once you abstract out logging, you get observability. How do you make this happen? Point number one, you log pessimistically, you log important things. So if you think that, is this really important, should I really log it. It's better to have more information than have less information. Okay, pessimistic is that basically this could have been useful in hindsight, so log like that. An opposite of that is point number two, logging is not a substitute for testing. Okay, so if there is something which you think is complex, test it, make sure it works all the time, it's perfect. That's the time when you won't write logs for unnecessary reasons. You won't say that, okay, if there's a mistake here, I'll need to know the ID of the thing. There will not be a mistake there. If you do testing, it's never going to happen. So you don't have logging as a substitute for testing. So you remove all unnecessary logging over there, but then you log pessimistically. So those two are going pretty well with each other. Do not log large objects. If you have a very large object, let's say a profile or something like that, where there's a lot of fields which are irrelevant, don't log the whole thing, just log the profile ID if you can. Or if there is a state change of the person's image URL, then you note down the state change, that's it. Okay, and the fourth thing, which is again opposite of point number three, is log with context. So you don't want to log large objects, the whole request object. I've seen this a lot, like the request comes in and every method is logging the entire request object. Why are you doing that? You just need it on the top. In any case, so logging with context means that log the ID of the request which has come in, because then you can just do a single grep command and read the whole problem. So I know a lot of you are from college, probably this is not making too much sense to you, but the general idea of logging is that if you get a request from a customer, okay, when you go to a bank, they give you a customer ID or a request ID. When they need to see what happened to that request, they need to be able to read all the details of that request immediately. So as software engineers, in a log, you want all the relevant data in one shot. That's logging with context. That's point number four. But you don't want unnecessary data corrupting your logs because you're going to manually read through them. So that is point number three. And also another thing about point number three is if you have systems which are using your logs, right? If you have machine learning systems downstream, then they have to clean that data. Data cleaning is a huge thing. You don't want to make their life also miserable by adding unnecessary information. Okay, so this is what I want to say about observability. And finally, system design helps you decide on trade-offs. This is something that if you go through my system design playlist, I think I've spoken about all of these. uh, this is on the internet. You can read up on these things anytime. You don't need to read it right now, but uh, a lot of these have been picked up on the system design playlist. Otherwise, you can also of course check them on the internet. Lossy versus lossless compression, I don't think I've talked about. Stateful versus stateless, again, I don't think I've talked about. But the rest, yeah, the rest have been talked about. Dev effort versus extensibility is another thing. So there's a lot of interesting points here. But yeah, maybe we can pick up each one of these topics in the channel later on. So that is the end of the talk. If you guys have any questions, do let me know. I will first be taking questions from Mr. Abhishek Kumar Shukla from NIT Warangal. But yeah, thank you so much for listening.
That was an amazing presentation, Gaurav. Especially the part where you talked about the shares and all. That was a really interesting story. So, thank you so much for that.
Thank you.
And to all the people on AirMeet and on YouTube Live, please subscribe to Gaurav's channel. It's really, really great for system design, competitive programming, interview prep, everything. You'll get the whole package over there. So go subscribe and watch those amazing videos. So let's move on with the questions that we have for you. So while we're at the topic of YouTube channel, let's start with it. So you have a big YouTube channel with around 309K subscribers, right?
Yeah.
So what inspired you towards the idea of creating your own YouTube channel, and how has the journey been so far?
So the journey has been excellent. I have learned a lot of things which I don't think I would have learned without being a YouTuber. I like me saying that term of YouTuber is also not something I would do as a software engineer, which shows that how much I've grown. So I started the YouTube channel. I think it was a transition from writing posts on computer programming, and then seeing people liking it, people commenting on it. That makes a big difference. I like when people say, "Wow, this is good." So I feel like all all the effort is vindicated now. So that I think was the start. Then I thought about what things would be useful for a Java developer who's also doing computer programming. So I tried YouTube, and it's something that stuck. I think primarily because in video this was the only platform out there, and even now I don't think Twitch is even close for an educator. So YouTube is pretty much the only platform if you're looking for educational content, which is zero barrier to entry.
Yeah.
Okay. And the journey has been great. That was the general idea.
It's awesome. So you are the founder of a startup called InterviewReady. So which brings me to the question that how can a college student prepare for a successful venture of his or her own?
Okay. InterviewReady has been formed after 6 years. I think 3 years was like focused job,
Yeah.
software engineering, and then what happened is I started getting an idea of what is interview preparation, because in my life I have switched companies twice, 4 months into Morgan Stanley and then just once into Uber. So it's not like I have a lot of interview experience as such, but I used to do a lot of computer programming, and I've seen a lot of my friends, all of them are in software. So I have a general idea. Of course, I've also taken a lot of interviews, a lot, I think. But yeah, so that gave me an idea that, hey, there's a lot of people who would like content on system design, but unfortunately the content is not well organized, or
Okay.
even the animations don't exist in many places, because maybe the effort is too much or whatever be the case. But I thought I can explain this much better through A, animations, B, making it more concise, C, making it more organized, and finally picking up things which are software related. Like one of the problems with any large company, I think, is that they try to put their hands in everything, while InterviewReady is still extremely focused on L1 to L7 software engineering interview preparation. That's it. So
Okay.
that way I have a small advantage. It's still a really small niche that I'm targeting. Oh yeah,
Okay.
and how do people become entrepreneurs in college? Well, usually there's an entrepreneur cell that will give you a lot more details of the basics that you need to get right. But one thing, should I just go for one thing? Yeah, one thing clearly, which is the most important thing for a college guy, is making your ideas sustainable. Okay,
Okay.
we all have a lot of ideas and dreams and hopes for making something which is super cool technology wise, making something which helps a lot of people, makes them happy, changes the world. But guys, that does happen when you make your product sustainable. Why is that the case? Because you're not holding a gun to another person's head and saying that please pay me. Actually, the please there will be a taunt. But what's happening here is that when you're buying a computer, the reason Bill Gates and Intel and everyone else is so rich, but you're happy with that because it's a willing transaction of money. You believe that this computer is worth more than what you're paying. That's the reason why you're paying that money. And Bill Gates believes that that money is worth more to them than the thing that they're selling. So it's a transaction where both people benefit. So in that way, you're helping people if they're buying your product. Okay,
Yeah.
that's one thing. Second thing, if you really want to be like super nice, you pay taxes. You're paying the government. There's nothing to worry about. And I'd say, yeah, in general, sustainable business models can grow. They allow more people to join you. You make a bigger impact in the world, not just by hiring more people, but also by affecting more lives through your product. So do look for sustainability. I have seen a lot of hackathons where a lot of people have good ideas, but they have absolutely no interest in making it sustainable, which is which is a bit of a problem. You know that are you depending on donations or on grants from the government? Because that itself is a challenge. It's not very easy to go to the government and say please pay me money. It's just the same way that you go to a customer and say pay me money. Okay, that's something I'd really ask you to do. Make it sustainable. Technology cool is good. Changes lives is good. Sustainable is right here. It kind of takes everything together.
Yeah. That's a really nice point that you made. So
Abhishek.
yeah. So another question is that we have talked about YouTube and we have talked about Interview Ready. Now you manage both of them. You manage a big YouTube channel and you earlier worked in a company and now you are having a startup of your own. So like how do you manage your time juggling between work and content creation?
It isn't easy, but what I think scheduling your day is super useful. I'm not sure if this happens very commonly in the US. I've heard it does. They actually schedule meetings with family also, which is very interesting. I hope to reach that level someday. Unfortunately, I didn't schedule my day for a long time after college. Like after graduating, it used to be like, okay, work takes 9 hours. Then I have no idea what I'm going to do, but I'm going to do something nice.
Yeah.
That was a general idea.
Okay.
Now I have realized scheduling is really useful. You say that this 1 hour is reserved for this presentation preparation. Okay. The next hour is reserved for reading. And then be kind to yourself. 2 hours is lunch and just chilling.
Okay.
Then yeah, then you might say on Saturdays I'm not going to have any schedule, which is fine. It's not too bad. You go down for football or you know watch a movie or something. But once you schedule, one of the best things that happens is that you know that the minimum amount of effort that you're supposed to put has been met. That makes you a
Okay.
stronger person. It really makes you more confident. You you feel happier uh, because you're doing what's required. What more can I do? Sort of attitude comes in. And I've tried both sides. I've tried not scheduling things and just working. But then you work for 14 hours in a day, and you do that for 2 or 3 days. Then you go like, okay, today is a rest day. Then the next day, today is a rest day. Then the next day is today is a rest day. So that is that's not sustained effort.
Yeah.
And eventually, I think that's why a lot of people hit burnout. They're making videos every day,
Yeah.
and it's very tiring.
So that's a pretty good idea of how to manage stuff. So moving on, yeah, having worked in both Morgan Stanley as well as Uber and DirectEye, what is the difference between software development related work in the financial as opposed to that of product based IT?
Okay, this is a tough question. I think IT, at least in India, or finance, is a lot of back end work. They call it business enabling. You can also call it support. Uh,
Okay.
it's interesting. It's not bad. It's not. It's nice. It's good. But a lot of the products are geared towards business analysts or people who are making decisions. I wouldn't say you're the core of the company, like like
Okay.
in Google or Microsoft or something. But there are interesting challenges to solve. Sometimes you are the core of the tech sector. You build libraries and stuff, and to some extent, or to a large extent, errors are not forgiven as easily as in product-based companies. So
Okay.
if you make big mistakes, there are big consequences also.
Okay.
Okay, I don't mean to say that the work culture is bad. I mean to say that the consequences are large, like you saw in the IPO thing.
Yeah, yeah, exactly.
So when you yeah, I would personally work in a product based company more, primarily because the biggest indicator, which is money, salary,
Hmm.
is more usually in the product based company than in the bank.
Hmm.
But there are many investment banks, many banks which actually pay very handsomely nowadays. So, but still, I would rather work in a product based company. I would rather work in a bank than work in a. Although this is not part of your question, but I'll still say it. Then no, I think I'll skip it. Yeah, I'll skip it. Yeah.
Yeah, okay. So,
And work in a service based company. Okay, yeah, go on.
yeah, okay. Yeah.
Nothing against people who work in a service based company. The
Hmm.
reason I'm saying that is because I truly believe that growth in a product based company or even in a bank is a little more than service based. Like I said, nothing against people who are working there. I just
Hmm.
believe that some of the work which is done by an entire team can be done by two or three people, if it's if it's probably handled well.
Okay.
I'm going to
Okay.
get a hate over here. Yeah, but okay.
Yeah. So let us move forward. You talked about competitive programming, right, in the PPT. So you talked about how it helps you to manage job interviews and all. So another point of view is that people like to do a lot of development stuff, like app development or web development. So what, according to you, is better to invest time in? Is it competitive programming or is it software development? And how different is competitive programming from real life programming that you do in when you actually working on a product or something?
So corporate programming is very different from real life. Yeah, if you have to do software development or computer programming, well, I would suggest do computer programming in the first and second year.
Hmm.
In your third year, hopefully you have already started, so you can focus more on development.
Yeah.
As for how different it is, it's, if I can take an analogy, it will be uh, joining the army would be software engineering, and running a marathon would be computer programming. One is a competition, well defined, nicely set. You have a set of clothes also, which is nicely defined, so you have a nice
Yeah.
environment also made for you. While the army is the army, okay,
Yeah.
of getting things done, and
Yeah.
running is a part, but
Hmm.
so is shooting, so is lifting weights, and so is cleaning toilets, which is
Yeah.
actually a part of software engineering. You refactor code and clean toilets basically,
Yeah.
and people get paid like really well for cleaning other people's code. So which is not taught to you in computer programming at all. Like refactoring code is something which is more a subjective thing, so it's readability. So yeah, I'd say like maybe 10% of software engineering is relevant to computer programming, but the rest not really. Why am I suggesting computer programming to you guys? Because it helps you in that get that 10% right, which is not a trivial number, but it's not
Hmm.
everything. So if you're good at computer programming, uh, that's great. You need to also work on the other things.
Great. So, yeah, this is the last question that I will be asking you. Is doing competitive programming crucial for changing roles from SDE1 to SDE2, or that only requires basic DSA skills?
No, it is not crucial. I For SD1 to SD2, the thing is you're a lateral then. So the you just need to prepare for interviews.
Hmm.
Part of it is problem solving and algorithms, but computer programming doesn't feature. Is learning algorithms a crucial part? Yes, it is. Without that, I think it's become standard practice now to test people on algorithms. It's highly unlikely that you don't know anything about algorithms and you're still going to be moving to SD2
Yeah.
as a lateral. System design actually starts there, SD2s,
Hmm.
and like at a decent level. They start
Okay.
expecting you to be able to, you know, argue about why this is good, why this is bad.
Hmm.
So I had suggest actually at SD2 start looking into system design much more seriously. And of course, SD3s the weight tips towards the system design side instead of the
Okay.
algorithm
Okay.
side.
Okay.
Oh,
So
that's an easy last question. That's good.
yeah, yeah. So yeah, that ends questions from our side. So now it's an open forum for everyone on AirMeet and on YouTube Live to ask questions. So feel free to post your questions, and Gaurav will answer your doubts and clarify your queries. So let's go with the first one that I have here. I have a question from Mohit Talreja. He's asking, when do you believe is the right time to stop CP and explore other domains of software development?
I think when you hit the problems where segment trees and heavy decomposition are the only things which are stopping you, and then you go into like really advanced geometry, you have to ask yourself a question about why is this happening? Like, why am I doing
Hmm.
this? So if you're going to get like really good at computer programming, it will help you get better at algorithms. Maybe you have a inclination for research then, but there will come a time when plateaus will be hit.
Yeah.
Plateaus are usually in computer programming when you're no longer interested as much to. No, I won't say that's the universal case, but in some cases we hit a plateau because the rest of the theory which is coming forward is too complicated to do.
Hmm.
Really, there's more exciting things out there. So when you hit a plateau, ask yourself, do you want to go to the next level, which is going to take you the same amount of effort that that it has till now, uh, and maybe that's a good time to stop.
Yeah.
Okay.
Okay. So the next question that we have is, what are the differences between an SD at a tech company like Microsoft or Oracle and an SD at an investment bank or e-commerce company, and how does that role change? It's by Chinmay Joshi.
Okay. I think we have talked about this.
Yeah,
That
to some extent we did.
yeah, about Morgan
Yeah.
Stanley uh, and Uber. But I'll take
Hmm.
the second part. How much does the role change? In an investment bank, the like I said, the growth opportunities are there. Even service-based company growth opportunities are there. Actually, in a service-based company, I'd say growth opportunities are more because you learn a lot of things and you have a large company, so you can sort of expand and it's more techy.
Hmm.
But growth opportunities in a company like Microsoft or Google are huge.
Yeah.
So the role changes a lot. You start designing systems, you start maybe managing teams. There's a lot of growth opportunity there uh,
Hmm.
than in, let's say, an investment bank where the use case kind of constrains your growth instead of the tech challenges.
Okay. So we have a question from Divas. Which one is more important for first 2 3 years into SD? HLD, that is system design, or LLD, that is object oriented.
I would say as you get more and more senior, they start expecting your LLD to be much better.
Hmm.
But yeah, in this start, HLD is asked a lot. So you are expected to be able to understand the overall thing, like load balancer. There's a message queue. You do some sort of sharding. and so more of HLD is asked for young
Mm-hmm.
engineers.
Mm-hmm.
But as you get more and more senior, they start asking you to code things.
Yeah.
So they might say that code this rate limiter or code this load balancer. So that's when your code quality becomes a real thing. LLD, senior guys, HLD, junior guys. But I have both of them in my interview ready IO course, primarily
Mm.
because there is a mix. It's not
Yeah.
like the senior guys will not be asked HLD and the junior guys will not be asked LLD. I've seen both happening. So I'm like, let's be safe. Yeah.
Yeah. Okay. So next question is from Afro Jackie. Can
Okay.
you also guide people who are already in the industry for like a year and now wanting to make a mark?
Okay. Can you also guide people who are already in the industry for a year and wanting to make a
Make
mark?
a mark.
In what sense? If you're talking about your team, how do you make a mark in your team? Okay, this is something that I've heard from a manager who's a very good friend of mine. Uh, the easiest way to make a mark in your team is to shoulder the responsibilities which have been given to you very well. I'll explain what that is. Let's say you are being given the responsibility to fix a button in a page. Okay, you might think this is not a big deal,
Yeah.
but as an engineer, you're representing your team. You're representing engineering. If you're talking to a person from operations, if you're talking to a person from HR, you're always representing engineering, Uber engineering. Let's say when I was in Uber, or direct eye engineering when I'm in direct eye. So your communication has to be good. That is point number one. Point number two is um, when you do something, there are no mistakes. Gaurav Sen writes code, the code cannot fail. That should be what it that should be a reputation you should go for. So Afrojack writes code, Afrojack's code never fails. There is no way in hell that a silly mistake will happen. If a mistake happens, it's maybe my code is making an issue. That's the time when people trust you so much that they start giving you bigger tasks. Like, let's see this whether this person can handle that. And so the manager's responsibility is taken away because they're seeing a person who's very serious about their work. You give them more work, they still deliver. Of course, they're going to give more and more to you. So that's one way to progress in your career, especially as a software engineer. Reliability is extremely crucial. You don't want a 2 o'clock call happening because of you, because nobody wants to pick up that call. And yeah, if it happens, don't beat yourself over it, but try to avoid it as much as possible. Yeah, you don't want to be the unpopular guy for your technical skills.
Yeah, of course. So we have a question from Anand Bahran Pukar. I am
Okay.
from third tier college and my resume is not getting selected in any company, not even for a test in off campus. I do have on campus job, but the pay is low. So what should I do?
Okay, one of the problems with off-campus application is the success rate is really low. My suggestion would
Hmm.
be, I don't know if you have tried it already, but I'll give you the same advice. Uh, go for people who you know. That is the first people you apply with in resumes. Don't be shy. There's nothing wrong in what you're doing. Second is go for people who are affiliated to your college, or maybe alumni, or people who you have seen in your college. You can send your resumes there. Chances are slightly lesser here. Then further reducing the chances, but something that you should do is check some companies that you like, apply there to the people over there, apply to HR. As I'm saying, the success ratio is getting lesser and lesser, but it's the only way that you can try for referrals. That's number one. If you're in college, off campus, it's difficult to get a referral even more because you don't have people in the industry to back you up with your experience. So contests is useful. It might, especially corporate programming, there are some contests where they say that okay, top 10 people will get an interview chance. That's not a very bad idea. If you're asking this now, it may be a little late to become really good at corporate programming and then come in the top 10. So it's a like I said, it's a tough question, but yeah, these two opportunities are there. If there are more, then I think people in the comments can help you.
Okay. So we have the next question from Priyansh. How to overcome the block which we face after reaching a certain level in competitive programming. For example, after a certain amount of time, the number of questions getting solved in a contest and ranks become static. So, like that plateau which you reach in
Yeah.
competitive programming.
I think reading on theory is very important. Then it's
Mm.
inevitable that your theory is going to lack after a certain period of time. Um, yeah, theoretical knowledge, like for example, like I said, segment trees. I can give you 1 minute. I can give you 15 minutes. It's not going to help if you don't know about segment trees, and if you know about it, you have already solved it.
Mm.
So, uh, in some cases, theory is absolutely crucial. It's not memorizing because like even researchers, they don't sit down and solve things, or even chess players, they don't sit
Yeah.
down and go like, wow, this queen will hit that, and they have a general idea of this happens, then this happens.
Yeah.
So they're able to take away a lot of the stress over here. Of course, they're smart people. That's the reason why
Mm.
they're in the top. But uh, the thinking is reduced to abstract
Mm.
moves instead of concrete. The queen will happen and then blah.
Yeah. So, okay.
Okay.
So we have another question from viewers. He asked how to prove to the interviewers that we are good at a particular language if we don't have a certification to prove it, or if we learn from online sources that don't provide a certification like from YouTube.
Um, but who's asking it? Is the interview asking it?
Yeah, you have to, prove it to the interviewer that I'm good at this skill, but like you don't have any evidence like a certificate or something to back it up.
It's hard. Like you have to prove it on the spot, which is then a challenge is given to you, right? They'll ask you, okay, here's a string in Java, and here's another string. So both of them have the value ABC. Where is it going to be stored in memory? So that is testing the theory of the language. Otherwise, they can ask you to write some code. I don't really understand what the question is getting to. If you are talking about how do you prove something, like short term, you can just write some code and solve a problem. For long term, it's impossible. So I don't know which company actually tests your language knowledge much,
Okay.
especially for a fresher. So I'll have to look into that.
I guess we have time for another
Yeah, one
one or
final
two
question
questions.
will
No?
be fun.
Yeah, yeah. So, how long should I work on a competitive programming problem before having a glance at the solution? That's a famous question.
Okay. My personal favorite way to do it was to actually try it in a contest, and
Hmm.
once it didn't work, check out the solution. There's nothing wrong in that.
Yeah.
But when you're practicing, that's the reason why I feel like practicing is so hard, because you can just hit the solution button and it works. So put
Hmm.
yourself in a contest. Lead Code has a way in which you can test yourself, like mock interview. I think
Yeah.
uh, the there's other platforms also which allow this thing that you're not able to see the solution. You have 3 hours, try to solve it.
Hmm.
So that helps a lot, because otherwise you're just going to hit the solution tab.
Yeah. Okay. I guess we can take one last small
One
question
final
because
question is
it's a
okay. Divyanshu Tyagi, right? Yeah.
yeah, yeah, yeah. That's a good question, I guess. Because he's asking, because of this pandemic, my session started late and all. So basically, what he wants to know is he has 6 months to prepare for internship interviews. Should he focus on competitive programming or do development and work on some group project?
Okay, so for a fresher, what would you recommend to do for these 6 months? Session started late, meaning, I mean, which year are you in, Divyanshu? That's important thing.
Um,
Due to the pandemic.
Internship interviews. So yeah, first
Oh,
year.
first year. Okay. Okay, you're in first year. Yeah, I think you can start with CP, corporate programming. Development work. So the logic of me saying that start with CP and then move to development is CP requires you to have algorithmic knowledge, which basically requires you, for you to implement it, requires just code. Okay, you don't need rocket science. On the other hand, a project can come up with any kind of problem. So connect it to a database. What's a database? Maybe you learn that in second year. You need to send a HTTP message from here to here. Some theory would help. That theory is going to come in second year or in third year. So when you start doing development a little later, it helps you because a lot of the theory which is going to come in your undergraduate course is taken care of. While corporate programming, you can start like I think you can start in 11th also. There's there's just math and coding. Okay, not 6-year-olds. We don't need any wolves in our place, uh, but yeah, start in first year is fine.
So I guess that was the last question, and this is a wrap. And thank you so much, Gaurav, for doing this session. This was really great, and I thank all the attendees in on Air Meet and all the attendees on YouTube Live. Thank you guys so much for attending this event, and please subscribe to Gaurav's YouTube channel, and check out his website InterviewReady. We will put the link in description, and check out the course because it's really really good. So thank you all for once again, and thank you so much, Gaurav.
Thank you, Abhishek. Thanks, Divas, for making this possible. Thank you to NIT Warangal for inviting me and making this session possible despite the pandemic. I hope to, I hope the people who are viewing this found it useful. You can, of course, like, share, and subscribe to NIT Warangal and also my channel. I mean, if you're but yeah.
Thank you so much.
All right, then. See you guys.
Okay.
Bye.
See you. Bye.